Welcome to the last video of Chapter 6, which is on Section 7, Dilations. So as you can guess, today we're going to learn about dilations. I think it would be best to start by talking about what is a dilation. So a dilation is a shrinking or enlargement of a figure to create a new figure. So you take a figure and either blow it up or you shrink it to make a new figure. And because you're shrinking or blowing up the figure, it's going to be similar to the original figure. So that's why this is in Chapter 6, is you're going to have two similar figures. So the figure that we scale by is this scale factor. If we scale by a number between 0 and 1, so a fraction like 4/5 or a decimal like 0.5, then the figure is what we call a reduction. So it's when you shrunk the figure. If k is bigger than 1, then the figure is an enlargement. So your new figure is bigger. So let's look at example 1. Okay, so example 1 says draw a quadrilateral ABCD with vertices given. Use the scale factor of 2. Let's start by drawing the original figure. So we have one point at A, which is 2, 1, which is right here. And then we have B at 4, 1. We have D at 1, -1. And we have C at 4, -1. Sorry that I went out of order. So your figure should look something like this. And now we have to draw a dilation. Let's use a scale factor of 2. Using the above rule, if k is bigger than 1, and 2 in this case is bigger than 1, the figure is an enlargement. So it means we're going to be taking the figure that we have here and we're going to be blowing it up. To find the new coordinates, all you do is multiply the old coordinates by 2, by your scale factor. So our new A, I'm going to denote it A prime, is going to be 4, 2. I just took 2, 1 and I multiplied by 2. The new B is going to be 8, 2. Again, I just took 4, 1 and I multiplied by 2. And then C is going to be 8, -2, and D is going to be 2, -2. And now we can graph it. So A is 4, 2, which is about here. B is 8, 2. C is 8, -2. And D is 2, -2. So yours should look a little more accurate than mine, but this right here is our dilation. So it's similar to the original figure, we just blew it up. So let's look at the second example. Okay, so example number 2 says you want to create a quadrilateral EFGH that is similar to the quadrilateral PQRS. What are the coordinates of H? So I know that this is a little hard to see, but we have this figure right here, which is ORSP, and we want to make another figure similar to it that's GFE, so this is EFG, and then some point H. And we have to find where that point H is going to be. We're going to start by marking the coordinates of all of these points. So mark them with me. I know it might be difficult for you to see on your paper. This point P is 3, 0. This point E is 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, I think. This point is 1, 1. This point F is 1, 2, 3, 1, 2, 3, 3, 3, I think. S is 1, 2, 3, 4, 4, 1, 2, 3, 4, 5, 4 comma 5, I believe. R is 0 comma 3, and G is 0 comma 9. Okay, so based on the problem, we know that we want E, F, G, H to go with P, Q, R, S, or to be similar to P, Q, R, S. Because this is a dilation, you know that point E was taken to point P. F went to Q, G went to R, and H went to S. Okay, so our point E is 9 comma 0. That became point P, which was 3 comma 0. F was 3 comma 3, and that went to Q, which is 1 comma 1. So this should be a Q, not a no. G is 0 comma 9, and that went to R, which is 0 comma 3. I'm just taking these points right off the figure. So we need to look for a pattern. What are we seeing? How do you go from 9 comma 0 to 3 comma 0? How do you go from 3 comma 3 to 1 comma 1? Well, you should notice for each of these, we are dividing by 3. So when I divide 9 comma 0 by 3, I get 3 comma 0. 3 comma 3 divided by 3 is 1 comma 1. 0 comma 9 divided by 3 comma 3, or divided by 3 is 0 comma 3. So the same token, H is going to be some point. When I divide it by 3, I get S, which is 4 comma 5. Okay, I know that point H should be bigger than point S. So rather than dividing by 3 to go backwards, I'm going to multiply by 3. When I multiply by 3, I get the point 12 comma 15. So I know in all these cases I was dividing by 3, but now if I take 12 comma 15 and I divide by 3, I get 4 comma 5. So point H is 12 comma 15. Okay, flip the page please. Right now, I would like you to do examples 3 and 4 on your own, please. Pause the video and come back when you are finished. Okay, so let's see how we did. For example number 3, for drawing the dilation, you should have multiplied each of the points by 3 over 5. When you take A and multiply it by 3 over 5, you get negative 3 comma 3. For B, you should have gotten negative 3, negative 6. For C, you should have gotten 6 comma 0. And let's draw the new figure and the old figure. The original figure has the point negative 5, 5, which is about here. That's the A. The B is negative 5, negative 10, which is here. And C is 10, 0. So this is our original figure, A, B, C. And then the new figure has negative 3, 3, negative 3, negative 6, and 6, 0. So in the red is our dilation. Okay, and you should notice that we have similar triangles. They look like the sides are proportional, and it looks like the angles are congruent. It looks like we took the black figure and we shrunk it down to get the red figure, which makes sense. When k is between 0 and 1, it's going to be a reduction, which is the case here. So hopefully we got that one right. And then I also asked you to do example number 4. So let's see how we did on this one. Find the scale factor from triangle ABC to triangle DEF. The first thing is that you should have found the points, found the coordinates. And I realized that it did not come out very clearly. It looks like D is 2, negative 2, I think. I believe D is 2, negative 2. F then is 4, negative 2. And E is 4, 1. Okay, and then it looks like our new figure, our dilation, looks like we have 4, negative 4, 8, negative 4, and 8, 2. So what happened is that point D became point A, point E became point B, point F became point C, and we can see that from our two statements. A, the first letter, becomes D, the first letter, etc. So D, 2, negative 2, became A, 4, negative 4. How does that happen? Well, I think I multiplied by 2. So let's check. E is 4, 1, and that became 8, 2. So I multiplied by 2 again. And then F, 4, negative 2, became C, 8, negative 4. So I multiplied by 2. So in this case, my scale factor is going to be 2. Okay, but I need to look at the question. The scale factor from ABC to DEF. So ABC to DEF. If I take a figure and I multiply it by 2, it should get bigger. So I actually went in the wrong direction. So rather than 2, my scale factor is going to be 1/2. Because I want to make my figure smaller. So to get from A to D, I'm going to have to divide by 2, or multiply by 1/2. Okay, so really, I should have looked at it going this way. From B going to E, from C going to F. When I go the reverse direction, rather than multiplying by 2, I'm multiplying by the reciprocal, 1/2. So you always have to see, am I making my figure bigger or smaller? Here I'm making the figure smaller, which is why the scale factor should be 1/2 instead of 2. Okay, example 5 I'm going to leave you to do. It says find the scale factor from DEO to ABO. So you need to look at how D changes as it goes to A, how E changes as it goes to B, and how O changes as it goes to O again. If DEO goes to ABO, that's an enlargement, so you should find a scale factor that is greater than 1. That's all I will tell you. It's similar to example 4. When you come to class tomorrow, I will expect you to have this question finished. Good luck.